This is the Unit 1 AP Microeconomics review. Now, a lot of the overlap topics, PPC and basic supply and demand, are actually in the Unit 1 Macroeconomics video, so you may want to watch that one as well because those topics are going to be on both the AP Macro test and the AP Micro test. And the Unit 1 exam for Micro will include things from the PPC and supply and demand. But we're going to go over topics specific to AP Micro. The first one we're going to cover is price controls. Now, we learned price controls in Macro as well. We learned that price controls deal with price changes and create disequilibrium, surpluses and shortages. And what we learned in AP Macro was only one type of price control, a binding price control. So we'll do those first. A binding price control, for example, a price floor, is when the government sets a minimum required price producers have to sell a product for. This is to help the producers. This is in a market where the producers can't exist at the equilibrium. So in this case, a producer can't operate at $2, the price is too low for them. So the government sets a minimum price, we'll say of $2.50 for an ice cream cone. Now this minimum price sets the price above equilibrium. This is the price floor. Now, because it's above equilibrium, it can only be this price or higher. Producers cannot sell below, meaning a binding price floor will always be at disequilibrium. And why this is a problem, well, you want to be at equilibrium, but why this is also a problem is at this artificially high price. Producers want to sell a higher quantity. They're like, yes, high price, I want to sell more at that higher price, which is the law of supply. However, consumers don't want to buy as much of that quantity because the price is too high. They want to sell it, we don't want to buy it. The quantity supplied is greater than the quantity demanded, which is why a binding price floor always creates a surplus. But there was another type of price floor we learned in Micro, a non-binding price floor. A non-binding price floor is when the government actually sets a minimum price below equilibrium. So they would say you can sell ice cream cones at a minimum price of $1.50. This is a non-binding price floor. Now, producers are still going to sell their ice cream cones at $2. So a non-binding price floor, because it's below equilibrium, doesn't actually affect the price of equilibrium. So with the non-binding price floor, A, you graph it below equilibrium, and B, when it asks, does this create a surplus or a shortage, you'd say no. Because if I'm a producer, this isn't really incentive for me. I still am going to sell it right here at $2. So a non-binding price floor does not create a shortage or a surplus. It keeps it at equilibrium. So it's not really an example of disequilibrium. Only a binding price floor is an example of a price above equilibrium that creates a surplus. Same exact idea, but with a price ceiling. A binding price ceiling is a maximum price we charge for something. So this is to help the consumer, to protect the consumer, so they're not paying a price that they can't afford. So let's say consumers can't afford $2 ice cream cones. So the government will set a binding price ceiling of $1.50. This is below equilibrium. So a binding price ceiling will be graphed below equilibrium. I know it's annoying, the ceiling's on the bottom of the graph, but you think of this as the cap. Anything below this, a producer can sell it for, but nothing above, which is why the price is always artificially too low in a binding price ceiling problem. And with this artificially low price, consumers are now like, yes, I want to buy ice cream. However, producers don't want to sell it. So now the quantity demanded is greater than the quantity supplied, and a price ceiling creates a shortage. If it was a non-binding price ceiling, just like the non-binding price floor, it's the opposite, where the maximum price would be above equilibrium. So a non-binding price ceiling would be, for example, a price ceiling, a maximum price of $2.50. Just like a non-binding price floor, this doesn't actually affect behavior because consumers are still going to buy the ice cream cone at $2. So if it asks, what does a non-binding price ceiling create, you'd say nothing. In fact, it just keeps it at equilibrium, versus a binding price ceiling that is one where it always creates a shortage and it always keeps us at disequilibrium. The next topic I want to talk about is elasticity. Now, elasticity goes hand in hand with supply and demand, but up until this point, when you've been drawing a supply and demand graph, like the one I had on the previous slide, you just assumed there was equal changes between price and quantity demanded and price and quantity supplied. At a higher price, we buy an equal amount less in quantity, or at a higher price, producers sell an equal amount more in quantity supplied. However, elasticity shows that not all goods have this equal change between price and quantity. Elasticity of demand, which we'll start with, shows that consumers react differently to different types of goods based on their elasticity. So if a good is very inelastic, I think of it as a need. So when the price goes up, quantity demanded decreases, but only by a little bit. So the change in price is greater than the change in quantity demanded. Or an elastic good, where it's more of a luxury, more of a want, when the price of the good goes up, like for example, if they raise the price of coffee, I don't need coffee, it's a luxury item. So the quantity I buy decreases by more than the increase in price. So to measure elasticity, we have two ways of doing this, and College Board accepts either way. One is seen as more accurate though, so we're gonna focus in on one, but if it gave you a scenario, like the top formula right here, where it's just percentage change in quantity over percentage change in price, it could say that quantity decreased by 20% and price increased by 40%. It could give you a formula like that, and you could use those percentages because it doesn't give you a range to go from, so you kind of have to use the percentage change formula. Now what we notice is this technically would be -2/4, but one thing that's really significant about elasticity is you use absolute value when calculating just plain elasticity of demand. So I would drop the negative, and I would just look at how my elasticity in this scenario is 0.5. Because what we care about in elasticity of demand isn't whether it's positive or negative, it's whether it's greater or less than 1. And if something is greater than 1, it means that the quantity change is greater than the price change. So it's an elastic good. Versus if the number is less than 1, like we have in this example on the board, that means that the quantity change is less than the price change, which means it's an inelastic good. So that calculation tells you whether a good is elastic or inelastic, whether it's greater than 1 in elastic or less than 1 in inelastic. Now the more preferred method is right here, the midpoint method. You still use absolute value, you still drop the negative sign. However, the midpoint method, which I have an example on the board, shows the more precise change in quantity over change in price. So if you have a range, for example, a price change and a quantity change, and you plugged it into the midpoint method right here, it would give you an elasticity of 2.32, which says that it's an elastic good, because if the number is greater than 1, the quantity change is greater than the price change. So that's how we measure, how we calculate elasticity. And we look at the ranges with that as well and how that looks on the graph. So from the far extreme to the other far extreme, we'll do perfectly inelastic. Perfectly inelastic is when you will pay any price for this. So the price goes up and down, but quantity stays the exact same, which is why a perfectly inelastic line is perfectly vertical. It doesn't really exist in the real world. Not changing our quantity at all with a change in price isn't very realistic. Relatively inelastic, which would be still pretty vertical, just not as vertical. This is when the number, as we said, is less than 1 because the price change is greater than the quantity demanded change. Unit elastic is exactly equal to 1. So when doing the midpoint formula, you would get your answer of 1. This means that the quantity change is the exact same as the price change. So up until this point, before elasticity, we assumed all graphs were unit elastic, that the price and the quantity change were exactly equal. A 20% increase in price caused a 20% decrease in quantity demanded. So that's just more of a normal demand line. Relatively elastic is more horizontal because when we see this, we have a greater quantity change than price change. And then perfectly elastic is perfectly horizontal because this is saying you will not pay a penny more than the price, your max price. And so if you're calculating perfectly elastic, it would be infinity. So again, not something you would see in the real world in terms of calculating it. You wouldn't calculate in the AP exam, but it just shows an infinite large number is the most elastic you can get versus perfectly inelastic, which is 0. So there are a couple other things with elasticity other than just calculating it and thinking about it graphically. We need to look at total revenue, which is a really easy formula. It's just price times quantity. So if I'm looking at this demand line right here, I could use the total revenue test to multiply the price of a good by the quantity demanded, and the firm's revenue would be $400. This, and whether or not a good is elastic or inelastic, helps a firm determine if they can make more profit by raising the price. If a good is inelastic and a firm raises the price, people are still going to buy it. So their total revenue will increase with a higher price. So a higher price equals an increase in total revenue if the good is inelastic. Or a lower price will decrease total revenue if the good is inelastic. Versus an elastic good. And in an elastic good, people stop buying it at the higher price. So if the firm tries to raise the price, their total revenue box will be smaller. So total revenue decreases at the higher price if it's an elastic good. And the opposite as well. If a firm lowers the price of an elastic good, total revenue will go up. So just think logically, a firm decides whether or not to raise or lower a price based on elasticity because that affects their total revenue. Another thing I needed to mention is the linear demand curve. So all of our demand lines look straight, but in reality they're not perfectly linear. But if it was perfectly linear, if it has a constant slope as you go down along the demand line, this is very significant for demand. Because what we notice, if we calculate the midpoint method as you move down along the line, the elasticity ranges change. Now again, this is only in a linear demand curve. So as I move down along the line, at first it's elastic, in the exact middle point it's unit elastic, and at the bottom it's inelastic. This graph will pop up a lot in later units, so you need to remember elastic at the top, inelastic at the bottom, and then that also affects total revenue because a firm has to think, am I on the elastic portion of the curve where lowering the price increases total revenue but raising it decreases total revenue? Or am I on the inelastic part of the curve where if I raise price, it'll increase total revenue? So firms need to know if it's a linear line to determine is it one type of elasticity or are there 3 ranges as you move along the curve. Another thing with elasticity is cross-price elasticity. This is looking at whether a good is a complement or a substitute. So cross-price, you're measuring related goods, the R in tripe. Now the formula is very similar to the formula for regular elasticity of demand, and you can still use the midpoint method as well. A lot of times it just gives you percentages to do it as an example. And what you're doing is looking at the change in quantity demanded of one good over the change in price of the other good. So you'll have to look at the change in price in one over the change in quantity of the other. And in this formula, positive and negative is absolutely everything. So you do not use absolute value in this formula because that number tells you if they're complements or substitutes. When we think about complements and substitutes just in regular demand, if the price of one good goes up, the demand for the substitute good goes up. If the price of Starbucks goes up, the demand for Dunkin' Donuts goes up. So there is a positive relationship between price and demand for the substitute good. So if you plug your numbers into here and it is a positive number, it's a substitute good. Versus complementary goods. If the price of a hot dog goes up, the demand for ketchup goes down. There's a negative coefficient between complementary goods, the price of one good, and the demand of the other. So if you plug 2 numbers and it gives you a negative number, the goods are complementary goods. So you have to use, if it's quantity demanded decrease, you have to keep that in this formula. Do not use absolute value if it's cross-price elasticity. The next important thing is income elasticity, which actually is very similar, except in change of quantity demanded of another good and price of another good. It's looking at when a change in income occurs, what happens to the amount of a good that we buy. So this helps determine whether or not a good is a normal good or an inferior good. So using actually, again, almost the same formula. So this is the third time we've used the almost exact same formula. Change in quantity over change in price. And that'll actually happen over and over and over again in the semester. So it's good to remember quantity over price, quantity over price. But in this case, it's change in quantity over the change in income. So it's still price, but it's our income number instead of the price of a good. So we're looking at the types of goods we buy when our income changes. And again, don't use absolute value. Positive and negative are essential in income elasticity as well. So if it's a positive number, that means that as our income goes up, we're buying a larger quantity of a good. It's a normal good. Or as our income goes down, we're buying a lower quantity of the good. So normal goods have a positive relationship, so it'll be a positive number. They go up and down together. And then inferior goods will be the negative number. Because if my income goes up and I buy less of a good, negative coefficient, that means it must be an inferior good. Or if my income goes down and I buy more of that good, that must be an inferior good. So inferior goods have a negative number between the two. And the last thing with elasticity is supply. The good thing about elasticity of supply is the calculation is almost the exact same as demand. You still use the midpoint formula or the percentage change. It's still quantity over price. It's just now percentage change in quantity supplied over price. So it's the same idea, but now you're the producer. And instead of saying, what type of good is this? Instead of saying, do I need it, do I want it? Elasticity of supply is saying, do I have the resources to produce more at a higher price? We know the law of supply. We want to sell as much as we can as a producer at the higher price. But the question with elasticity of supply is, are we able to? So it's really looking at the availability of resources to determine elasticity of supply. So things like, is it a finite area, beachfront land, seats at a concert? It's more inelastic because you can't keep reproducing it, versus manufacturing goods, which you can keep producing it. You have more access to resources. Now, the number one thing is time. The more time a producer has, the more elastic the supply is. So if it's today, if it's right now, and they have to sell it, it's inelastic. They don't have the time to get the resources to sell more at a higher price. But if they have a month, if they hear it'll sell for a higher price in a month, they have time to get the resources to sell more at the higher price. So the more time, the more elastic. And this just goes for resources in general. Time is the most common one and the most important one, but other resources, land and labor, if they have access to more resources, the supply is more elastic. If they don't have access to the resources, the supply is inelastic. So moving on to consumer and producer surplus. Consumer and producer surplus isn't hard. Surplus, think gain. So a consumer gains if they don't have to pay as high of a price as they thought they would have. So a consumer surplus is the price below what they were willing to pay for it. Versus producer surplus, a producer wants to sell it for as high of a price as possible. So if a producer breaks even, it means they're selling it for the same price as their cost of production. Any price higher than that is producer surplus. So price on top of the cost of producing a good for the producer. And if we have to calculate it, we would use this formula right here. Height times space divided by 2, because what we're looking for is the area of these triangles. If we needed to calculate what is the consumer surplus, what is the producer surplus. So this is the basic graph for consumer and producer surplus. At this point, at equilibrium, we are maximizing our total surplus because we are producing at equilibrium quantity. Everything that is below the demand line, and right here is the consumer surplus, and everything that is above the supply line, and right here is the producer surplus. Out here doesn't really exist because this represents producers whose costs are too high to operate in the market, and this represents consumers whose value of the good is too low to buy the product in the market. So we're really looking at this area right here. That's our surplus. And so with that, we have to look at things that change price and equilibrium and surpluses and shortages to say what happens to consumer and producer surplus. So it's an easy concept, but anytime we change something later on in the semester, it'll change consumer and producer surplus. You have to keep this basic idea in mind the whole semester. So for example, if it's a price change, this ends up being bad for society, which at the beginning we said prices create disequilibrium, shortages and surpluses. So they also hurt producer and consumer surplus. So if it's a price increase, let's say price goes up to $2.50. If price goes up to $2.50, I'm going to bring this all the way down here because now this is going to be the quantity producers are willing to sell. So it brings our quantity from 7, where it was at equilibrium, to 4. And this is a really important difference because by moving our quantity down to 4, we are actually decreasing our total surplus because now we have a new area right here that didn't exist before, and this area is known as dead weight loss. Dead weight loss is always bad. Doesn't gain anything for the producers, doesn't gain anything for the consumers. It's just a lost quantity that they should be at if they're at equilibrium, but they're not. Also, at this new price, now my producer surplus is everything below here. So it does increase producer surplus. However, it decreases consumer surplus to this triangle right here. And the problem with that is it actually decreases consumer surplus by more than it increases producer surplus, which is also why total surplus goes down. So yes, in a price problem, it does help the producers. But because it ends up decreasing the quantity and it hurts consumers by so much, it's going to end up being a problem. And that's when we end up having surpluses, is because consumers are not willing to buy what producers want to sell. Or if it's a price decrease problem, if the price is lower, this would help the consumers because now the consumers are able to pay a lower price for the good. But again, we notice it lowers equilibrium quantity. So again, we have this triangle right here of dead weight loss that goes to no one at all. And although consumer surplus might increase to this whole area, producer surplus is now this tiny little triangle. So a price decrease, although it does increase consumer surplus, it decreases producer surplus by more than the increase in consumer surplus, which is why there's a total decrease in surplus, or total surplus decrease, and why there's dead weight loss. So it's not seen as a good thing when prices go up or down for consumer and producer surplus. Versus an equilibrium change. Equilibrium change is a little bit easier. When you're looking at an equilibrium change, all you have to think about with consumer and producer surplus is what happens to the equilibrium quantity. Does equilibrium quantity go up or down? That tells you what happens to consumer surplus, producer surplus, and total surplus. So for example, if demand increases and we have a new equilibrium price and quantity, we have a new range for consumer and producer surplus. And because we have a larger equilibrium quantity, then we have more room for more consumer surplus, more for producer surplus, and more total surplus. So an increase in equilibrium quantity increases all the surpluses, which the opposite is true as well. If we have a decrease in equilibrium quantity, for example, a decrease in supply moves to the left. Now, at our new equilibrium, we have a smaller equilibrium quantity. So now our surplus is just this tiny little box for consumers and this tiny little box for producers. It's smaller all around. So equilibrium quantity decreases causes a decrease in consumer surplus, producer surplus, and total surplus. So they move directly with equilibrium quantity. The last thing I want to talk about is taxation. Now, taxation can be on the consumer and the producer. On the AP exam, you'll see it on the producer more likely than not, because when we learn tripe and groats, the government was with supply, taxation moves supply, so it sticks with that, although it is possible for the tax to be on the consumer as well. So I will show you both. But no matter what type of tax it is, it creates a wedge. A wedge that represents this box right here is the tax. Because let's say this is a $30 tax. So this will be $30. So if this is $80 and this is $110, the size of the tax is $30. Then, so this is the tax right here. And when the government places a tax on the consumers and the producers, they both end up bearing a good chunk of the burden. Now, it also depends on elasticity, which we'll talk about, but almost always both have some of the burden of the tax. So what we notice now is because of the tax, consumers now have to pay a higher price. They'd have to pay $110 for this good. And producers now don't receive as much as they did before. But the government, in placing this tax, gets what's known as tax revenue, which is just the size of the tax times the quantity. So that's revenue to the government. Doesn't go to the producer, just goes to the government. So if they need revenue to fund the government, they may think about increasing or decreasing the tax to try and increase or decrease revenue. But then what this does is it changes consumer surplus to just be this tiny little triangle. It changes producer surplus to now just be this tiny little triangle. So it decreases both consumer and producer surplus, and just like a price change when we did consumer and producer surplus, it creates deadweight loss. This is lost to everyone. The government doesn't get it, the consumers don't get it, the producers don't get it. It's just gone, which is inefficient, again, in a marketplace, because we are no longer at equilibrium quantity. So very similar to deadweight loss in a price problem in consumer and producer surplus, except now it's caused by the government taking money in a tax. Now, who bears the burden of the tax can also be affected by elasticity. Because when you have a tax placed on a consumer, if it's an inelastic good, nobody wants to pay a tax, but if you need it, you're still gonna buy the good. So if it's an inelastic good and the tax is placed on it, you will bear the burden of the tax. So in that case, the consumer would bear the burden of the tax because it's an inelastic demand. This also means deadweight loss wouldn't be as large, because deadweight loss is determined by how much less the quantity is. So if it's inelastic, the quantity doesn't go down by as much, deadweight loss isn't as large. Versus if they tax an elastic good. If it's an elastic good, it's a luxury item, it's a want, I'm just gonna stop buying it if it's taxed. So my quantity is gonna decrease by a ton, which is then in turn gonna create more and more deadweight loss. So if it's an elastic good, the consumer, if it's elastic demand, the consumer isn't as affected by it because they just stop buying it. But this also means deadweight loss is really, really big. And the government doesn't get as much revenue because we just stop buying it. Same with inelastic supply. If it's an inelastic supply, the producers bear the burden of the tax, and they still have to produce that amount. They don't have a lot of flexibility yet. They don't have the time to get new resources. And so the deadweight loss is small.